Good evening and welcome back to my heat exchanger template design series. So this template is meant for students, young graduates, and um, small company that's looking into designing heat exchangers, building heat exchangers, even if it's a hobby, if you want to figure out if your design makes sense before you actually go and procure the equipment, this is the show for you. So I found another example on DWSIM. It was a stream of natural gas that was at 30 degrees. And what I decided to do was to try out having two two gases basically. So a gas and a steam. So saturated steam on the one side and natural gas on the one side. And to make the example consistent, what I've done is I've set it up in such a way that your heat exchanger, it's set up that the outlet of the saturated steam always remains saturated, so we don't get condensation. So the next example I'll do is I'll find a nice example of condensation. For this one, I wanted to give an example where you deliberately ensure that you have enough steam running through the exchanger so that even if there is a temperature drop, for example here you're moving from 396 to 374, you still maintain only vapor, right? So you do that by specifying the outlet vapor, or the outlet stream should be vapor of the stream that you want on DWC. And then your natural gas, the flow that it had was 10.32 kgs per second, and then it moved from 303.15 Kelvin to 354 Kelvin. So I want to try and test if this will work and see how our spreadsheet responds. So I've already opened our spreadsheet. If you were here last time, you'll see we were doing a a gasoline and water mix. So what I'll do now is we'll go back to raw data and we will put in the new sim data. So again, you go to material streams, make sure that's up to date, and then you copy to clipboard. So I just want to check if our streams are properly labeled and obviously to see if our system will be able to pick up the names of the compound. So I did that deliberately where in naming my streams, I only named the inlet streams to see how versatile the coding is on the spreadsheet, because I had set it up in such a way that the moment you give it your data, it's able to name the two streams. Okay, so first things first, we paste in the data. Okay, one thing you'll need to note is I've set this up for a certain set of units which I custom designed or custom selected on DWSIM. So when using this spreadsheet, this is something you need to be wary of, or this is something that I would need to modify the spreadsheet for you so that it basically uses the units that you want. For example, let me just take you to the standard SI units. If you go to the standard SI units engineering, you'll see it matches most of the units that I'm using. So I'm using bar, I'm using watts per meter Kelvin for the conductivity. But this is something that you need to check. But then here on the mass flow rate, it uses kgs per hour. But the spreadsheet is set up for kgs per second. So this is important to note that you match the units. Otherwise, it will not work properly. Okay, let's go back to the spreadsheet. So again, what I'm doing this series for two reasons. One of them is to try and break the spreadsheet to see if there's something that I might have missed in the construction of the model itself and then the background coding that was added. So it's to check that everything is still working as it's supposed to. The other thing also, I'm using this platform, to practice my presentation skills so that I get better at presenting these series, and my audience can enjoy more. But also as an engineer, you do a lot of communication, so it's good to practice speaking, presenting your ideas so that you can use that in the workplace, you can use that in the business market. Okay, so first things first, I want to check if it picked up the streams. So as I can see here, the hot fluid, it only gave it the number 7, and then it was able to pick up the cold fluid as natural gas. So now let's go back to the simulation and check if that would make sense in terms of, so it wouldn't. So now, as you can see, it said the cold fluid is natural gas, right? And then um, the hot fluid, it also gave natural gas. So it picked up the natural gas going out. So what I'll try to do now is I'll try to change this to natural gas in and change that to natural gas out. So this is a bug that I might have to change in the coding itself, but let's see if simply changing the titles will actually help. And then saturated steam in and saturated steam out. Okay, so we're gonna update our material streams again, and then we copy to clipboard, and then we want to see if our naming will be correct. I'm not so worried about the allocation of the streams, because that, in my understanding, as I mentioned in my previous video, is governed by the mass flow. Okay, so now as a hot fluid, it has natural gas in, and as a cold fluid, it has saturated steam in, which again is wrong. Let's see the allocation on the actual streams. So the best way to check is, first of all, to make sure that on the tube side, as again, you've got the same flow, and on the shell side, you've got the same flow. So in terms of allocating, right, the spreadsheet didn't get it wrong, right? The only thing it got wrong, right, was specifically checking which one is which. So we know that the natural gas is the cold fluid, and the hot fluid is the saturated steam. So let's check again. On the service, it's allocated properly. So tube side service, it's the cold stream. So that's on the tube side, and it's moving from 303 to 395. That's fine. And then on the shell side is the hot stream, which is moving from 396 to 374. So in terms of allocation, not bad. I'd like us to go through the presentation, and then what I'll then do is go back and check where there could have been an error. I'm also noticing something here. We've got something reporting in the liquid. However, the phase fraction is saying 1. So let's just check the decimal places, which is fine. So this is definitely a bug that needs to be checked, because this was supposed to not find anything. So I'm going to highlight that for myself so that I can check it later. Okay, let's see how much of an effect that will have. So again, we then need to go in. This is not liquid liquid. We can go gas gas to see if that responds. Okay, and then what we'll then need to do is to check that the tube side property basis is okay. So it is using the vapor side instead of using the liquid side, which is fine. Then we'll need to confirm if there are any other mistake. So again, I'm gonna use kern here. If you noticed last time when we were doing this, there was a problem with the there was the problem with some of these drop downs, and the reason why was because the the sheet was locked. So that I've corrected. Then next, we're going to choose the correct allocation so that we get the following factors. So on the shell side, we've got the hot stream, and the hot stream is the natural gas. So if you check on the stream name, no, the hot stream is the saturated steam, which is correct. So shell side, I'm gonna change that to saturated steam. Let's see if we have. So here it has condensing steam. We know we're not condensing, so we must be careful there. Steam condensate should be fine. Okay, and then on this side, we've got natural gas. See if we have natural gas, otherwise we can go with light hydrocarbons. Okay, that should be fine. To mix things around, let's choose another material of construction. This time let's use stainless steel 316. Okay, go on, and then first we're gonna check if our number of tubes are within reasonable range. It looks okay, and then I'm just gonna change my overall coefficient estimate to see where it converges to. Okay, it converges to 133, which might be a bit of a concern on the area. We will check on we'll check once we've updated everything to see how it responds. You can see here the manual values haven't changed, but if you come and check, the auto selected values have changed and they are giving you the correct value. That's something to look out for when you are using the spreadsheet. So next, we're going to update the design area, run the optimization, update the datasheet section. Okay, and then lastly, we're going to generate the drawing for this specific to make sure the drawing is correct. And then next, we generate the technical report. I could easily just go into the other tabs to see the design report before I even do anything. So for example, to come check if the design status is okay, you can see that your number of tubes are okay. Let's just go to the values. Your shell diameter is okay, it's less than 2000 as we have specified for this particular system. The one that I'm a bit concerned about, which I'll need to check, is this value. I've noticed it's not changing, so I need to go find it so that I can check. I also need to check this value. Material of construction is not updating. Something that I need to go back and check. The fun part about developing models is once you've developed the equations and you've done the base work, the core work, right? It becomes easy for you to debug once you start adding in the coding, right? So it is important to understand how to build a model from scratch so that later when you update it and you put in more functionality, right, the core debugging is something that you can do on your own without external help. So I need to find the Reynolds number for, let's just go back. This is tube side Reynolds number. So I need to come to the tube side. So there we have 48. I just need to confirm if this is the tube side. So there is a transfer coefficient. There, I think the best place to see it would be on the inputs. So there's definitely something wrong there. Good. Just need to map it, find it. This data that I'm missing here, or I can't see, I just need to make sure that I highlight it. So that's the shell side, and this is the tube side. I found what I'm looking for. I had lost it in my formatting. Okay, so now the Reynolds number is 48.31. It's not updating. Again, it's a small Reynolds number, so you'll need to check again on our checking basis. You'll see that here it requires your Reynolds number, your tube side Reynolds number, to be greater than 2001. So, which means there is definitely a problem that needs to be checked. Right. So, what I can do here is I can immediately update that. So I'd lock that sheet, let me unprotect, so I can do the necessary correction. So this already should have flagged, and what it will do now, hence there's an issue here. I'll need to fix this one. Something put this as hard coded. So now if C61 is this one, I need it to be greater than 2000, is greater than 2100, then it's okay. If not, you need to check. Oh, I'm not reading that number right. It is 48,000, so that's fine. I thought it was 48,000, so that's fine. Okay, but then that was not reading, so now at least we know it's fine. And then just to confirm, let's just change that to example to 1.8. Then the spreadsheet will tell you to check. Okay, so we're good. Just some troubleshooting there, so we're okay there. So now it's reading the correct value. I just noticed that this value was not changing. I just need to confirm. And then the tube side velocity as well is not a hard number. I need to go and find it. Tube side velocity. Tube side velocity. I calculated it. Let me just update it to ensure that all the necessary warnings come up when they're supposed to. Can't find my... Okay, as soon as I find it, I'll update it. So tube side, you've got your mass velocity. I can always calculate it from here, but I want to make sure that the calculation is here. Okay, and now I'm gonna leave it. I think it might be hidden in one of these. Okay, let me highlight that so that I don't miss anything. Okay, so this is overall pressure drop calculations. Okay. My velocity is hidden somewhere here. I need to find it. That's the problem of formatting such a big spreadsheet. You end up losing some of your, make sure that I can see that. Okay, I'll need to find where I calculated the velocity, and I'll update the velocity verification. 1995. Okay, I found you. This is the tube velocity. There we go. Excuse me. So now need to make sure that that auto updates. Okay. So to make sure, okay, change that. So now we need to make sure both are fine. So this one must be greater than 10, and it must be less than 30. So it will tell us to check your velocity is too high. So one of the reasons why I would love to have some test subjects, if I can call you that, for you to go through all these checks and make sure that everything is responding the way it's supposed to. So that is the reason why I will try to, on a daily basis, do a session so that I can go looking for these bugs while you are here, while you're watching, so that by the time you purchase the spreadsheet, you know that we've gone through the bugs together and you know how to look for more bugs so that I can update it and you can always have the updated version. So one of the specials that I'm running is for the students and undergrads and anyone who will be a first time buyer, right? The first year license, any updates that happen during that time, you will get it for free. So it will be a once-off purchase. So for students, it will be kept to 550 with the requirement that you do at least one tutoring session. For young graduates, it's gonna be put at 5,500 for a license, and that will also apply to individuals that want to use it in a design setting. However, after a year, once we've gone through the bugs, all the versions during the first year will be free, all the updates will be free, and then after a year, then it will be reviewed to buy the next version that will come up after that. So it's an exciting opportunity to, one, learn with me as you go, because as you are giving me feedback before I even update it, I will be doing it with you on a Teams call to show you how to get rid of that bug that you saw, and also that hour that you would have booked me for, right, to go through what you saw will be used to also look at the design principles behind setting up such a model. Okay, so the one bug that I need to fix here that I was not able to now is why that is doing that, but also the fact that the identification here is wrong. So that's one thing I'll need to check, because as you can see, the hot fluid, right? The hot fluid is on the shell side and the cold fluid is on the tube side. So this is something I'll need to update. Okay, I'll just need to unprotect. Now this should be a quick fix, because already, no, this won't be a quick fix, because the problem is if I use this section, this will always update depending on the selection. So I'll just need to find it. Some of the cells have actually removed. detected hot stream. Okay, this mapping is not right, so I'll need to change this. So for now, I'll leave it like that, and I'll take a deeper look. All right, in any case, that's where I want to end it today. The spreadsheet, oh, the one thing I did last time is I was looking at the area. So I just want to check what kind of area it's giving us. So we can go to the design report. This we can immediately go to the downloaded design report. So for date for today, if I go to my classes, this is the report that we did. We can take that. Then we can jump the design philosophy summary and then go straight to the report itself. So what are we looking at? Okay, let's start here. Okay, so sizing geometry, your required area 136 meters squared. Your shell diameter 11.59. So we're not bad. We're not bad in terms of the dimensions. Tube length 4.88. So 1.1 meter diameter, not so bad. That's our L over D pass. L over D ratio is between 3 and 15, so it's okay. So the design is not bad. So the only thing now that I have to look at is that issue. As you can see, it's updated gas to gas. Properties reported correctly. Your thermal data, so you've got your heat duty minus 926. It gives you your delta T log min. So overall, the design looks good. The design looks good. Okay. You've got your shell side coefficient, tube side, fouling as we discussed. Okay. Overall, it looks good. Overall, the design looks good. We only have one warning. I need to debug that. It's showing as a date instead of a number. It meant to say, so I need to go back here and make sure that on the design report, that never picks up as a date. It's now picking it up as 15 March. So I just need to update that so that it reports it correctly. Okay, and there's your representation, your graphic representation of your heat exchanger. So you've got your shell diameter of 1.59, you've got a bundle diameter of 1.134, so that's your tube bundle. You've got a length of 4.88, tube count 1128 tubes. It's a good design. It's a good design. All right, so I'm gonna end it there today. I hope it was a good session for everyone. I'm gonna go back, work on the bugs again, come back tomorrow with another session. Hopefully we find more bugs. Hopefully, as you are coming along with me in this journey, it is interesting and you're learning a lot, and I hope to start getting a lot of calls. The conversations I'm having so far are very enlightening. I appreciate the feedback from students that take that time to go through the videos, see if they can pick up stuff just by viewing the videos. But it would be nice so that we start interacting on Teams live. For those who'd like to book a session, if it's just for viewing, viewing how the spreadsheet works, those sessions will be free. So please drop me a WhatsApp, drop me a comment on YouTube. Let's engage, let's book those sessions. Ideally, I'd like to have more than one person at a time so that we can go through and it will be easier to see if there are any issues when it's a large group than just one individual. Thank you very much for your time. I hope you had a great time as I did. Have a good evening.